Project Winter Village, episode number 2. In the first episode, we talked about the electric brick and how we created it. And this time, we go one step further and want to place the first LED lights in our build. And there are not too many things we need. Here the enameled copper wire, some LEDs and resistors. And that are our basic ingredients for what we are going to do. We could directly jump in and do the soldering and the placement of the lights, but you might be interested in some background and how you select the light source and how do you set up the resistors for your build. When we talk about our small electrical circuit, we start with our light source, our SMD0805 diode. Roughly, the graphs for our diodes look pretty similar, but they have particular differences. And I picked here one for the orange diode. And you can apply a different current to this diode. And you want to operate the diode in a specific current range, else it's too bright or you start destroying your diode or it's too low in brightness. In earlier builds, I figured out that 6 milliamp is a good value to have our diode shining not too brightly and not too low. In the diagram, you can look up what it means if you want to drive the diode with 6 milliamps. Then the voltage drop is 1.75 volt. And how do you read it from the chart? So on the y-axis, you go to 6 milliamps. And when you start crossing the curve, then you go down to the x-axis. And this gives you the value of 1.75 volts. This is the operating point we want to hit. And then we grab our formula, R equals to U divided by I. And with this simple formula, we can calculate the resistance our diode is having. And out of curiosity, we can also calculate P. That's the power loss of our diode. And there's the simple formula, P equals U times I. And with that small value, you can just multiply it with your amount of diodes you are using and you will know if your power source is good. But if you apply it to a few houses or let's say 50 LEDs, you're probably good with your power source. And here I completed the chart also for the 15 milliamps and the 20 milliamps. That is operating range in which you could operate the diode if you would like to get it a little brighter. And you see that the ohmic resistance is different and the power consumption is also increasing. That was a deep dive for our diode. But we also need a little more to get the complete circuit running. So you need to select the power source. And in my case, I found a power supply of a laptop, a small one, and that one is supplying 12 volts. It's good to have a 12 volt range and not just 5 volt. With a 12 volt range, you could operate more diodes in series before you have to place a resistor. Most of the diodes I would like to drive with 6 milliamps. It could also be higher if I want to make the diode shine a little brighter. And that one gives you with the easy formula R equals U divided by I, the one we just had also used before. And that one tells us that the overall resistance should be 2000 ohm. And with 2000 ohm, you will have a current of 0.006 amps. And that is exactly the value we would like to have for our diodes. In most scenarios for the build, it is convenient if you can put a few of the LEDs in series connection, so just one after each other. A series connection means you can add up those values and you come up with a voltage drop of 7 volt. That is over the complete series connection of those 4 LEDs. The same is valid for the resistances. They also just add up. That is a resistance value we took from what we learned before. We selected 292 ohms to get the LED down to 6 milliamps, adding up to a total resistance of roughly 1200 ohm. And if we operate our LEDs in this range, that is the sweet spot, and then we have the brightness we would like to have. In the upper part, we learned that our R overall should be 2000 ohm to generate a current flow of 6 milliamps. And our LEDs are just adding up to 1200 ohm. So there's a discrepancy between those values. And now we have to do something to hit the 2000 ohm. And what do you do to get the ohmic resistance up? You just take a pre-resistor and put it in series connection to your small circuit. Here in this case to our 4 LEDs. And here our formula gets even simpler. We say our pre-resistor shall have the value of the overall resistance we would like to get minus the sum of our LEDs, our 2100, and that brings us down to a pre-resistor of roughly 800 ohm. And here we go, our theory part is done. We now know that we can use a pre-resistor of roughly 800 ohm that allows us to operate our 4 LEDs in series connection as long as we use our 12 volt power supply. We switch from our theory part to the practical part. So let's take the lights off and see where we can place our diodes. The bottom side is pretty closed. The top side has the candle, though there's not really an option. We have to take the drill and we have to go in there at some point. Now we would like to make sure that our small 0805 diode is also fitting in that hole we just drilled. So let's grab one of those tiny elements and we look for the fit. Looking good. So we can go ahead and we take our enameled copper wire and we somehow have to get the coating away from the wire. So we raise the temperature of our soldering station to 350 degrees or even higher. And with the high temperature of our soldering iron, we can simply melt away the coating of our wire. As you know, our diode is really tiny, and if you try to solder it just lying on the table, it will easily stick to the soldering iron and get destroyed. So as a small helper, I like to use some double-sided tape, and I just put the diode to it, and you have a good and solid support. And now we start soldering the part. And since that is a repetitive process, I ramp up the speed a little in the video, and you see the soldering. Again, we have to take away the coating of our enameled copper wire and the soldering of the other side. Let us see if the diode also will fit to our small candle. So we have to bend the wires and we want to make the LED shine to the top side, or else the candle will look funny if it's just glowing on the bottom side. When we place our small candle in the build again, we will have some pull forces on the wire and we will easily rotate the diode or pull it out again. And that is why we take here some adhesive tape and we fill the hole with it. Advantage is it is also wide and you will hardly see that there's a hole in the candle, especially if we turn this one to the back side. We are done with our first candle and we can directly start with the second one. So the same process, we drill our hole and we get the SMD LED ready. When you place SMD diodes in a row, just make sure that you care for the direction of the diode. You have a minus and a plus side, and the flow has to go along those diodes, so it has to have the same orientation always. Here we are bending our wires again, that the diode is shining to the upside, and we use our filler tape again to make our cables and the diode get stuck in the position where we would like to have it. If we did everything correct, our first 2 candles should now shine nicely. And I again ramp up the speed. And we will do exactly the same for our LED number 3 and 4 for our 2 candles on the table. Let us turn on the light and let's see if we connected all the diodes correctly and if we can get those candles shining. Yes, it did work. Okay, we don't have to take them apart again to fix something. And our candles have a nice and orange glow to the top side of the flame. Let me quickly show you the test setup I did build to test our electric circuit in advance. We have the inlet of our power supply, and I placed a fuse here to make sure if I have a short circuit somewhere that the fuse is opening and that we don't start having glowing or melting wires. I use then from a model railway simple distribution bar. There you have the plus on one side and the minus on the other side, and you can simply put plugs in and out. The brick box just helps us to keep everything in place, and from there we connect simply via wire to our test board. Now we grab our electric brick from the first video, and here I added the resistor we calculated at the beginning of our video. In addition to that, the left connector is now wired directly through to the right connector, and then we have again a plus and minus source in this house. And if we want to connect to the next house, it's now easily possible by not going to the main power source again. We can easily plug into this electric brick. And the next big milestone we take to our model, and let us see if we can place everything where we want it and if the cable length is good. As it turns out, everything can be placed at the position where it should be, and the wires can be hidden behind the table, behind the chair, and behind the oven. And now comes the big moment. We dim the lights and see if everything is working as we imagined. I really like it. It seems like we hit the brightness correctly. It is a nice glow and it's not too bright. And our oven and our table is now nicely lit. What is your opinion? Glad to hear in the comments, and see you in episode number 3.